Good morning, everyone. We didn't have our intro music connecting us to kind of give us a little cue that it is 11 o'clock, but we are going to be getting started here. So if you are, as you are all logging in, I'm going to just provide a little bit of an intro before we turn it over to our main speaker today. So as we're getting started, I'll introduce myself. My name is Tom Reed. I am the program manager for the Energy and Manufacturing in Appalachia program. I am happy to do the intro. Most of the work for these Fuel for Thought webinars is pulled together by Matt Henderson, who you probably have seen some communications around this piece. And so he puts all this together for us, helps to coordinate the webinars that we have and helping me to find good guests. So glad to have him here helping with that. Speaking of which, if you have an idea for a good topic, feel free to reach out to me or Matt, and we'd be glad to do so. But I think, for the next couple of months, we've got a really jam-packed plan for some great content. And so I'm going to talk about that before I turn it over for today's topic. But first and foremost, I would just encourage you to go to our website, the wemakeithere.org/energy, to learn more about the EMA program. We cover 156 counties across 5 states, and we have a combination of partners, Catalyst Connection, who I work for, as well as about 10 other groups like MEP networks and others who are in the energy and manufacturing worlds, helping to support these efforts. So I encourage you to go to the website. I'm going to go ahead and put that in chat so that you can see that if you want to go and look at that at a later point. And while we're talking about links, we also have a LinkedIn group that is just for energy and manufacturing in Appalachia. It's a great place to get and share the latest news of what's going on in this world. So please visit those 2 sites to get more information. Today is the first of our energy supply chain overviews. And so this is the next big focus that we have as part of our program. And you can see, in addition to our natural gas carbon capture topic today, we already have on schedule nuclear, onshore wind, AI data centers overview, and battery storage. And then we have a whole list of additional topics that are in process, including a deep dive into more of the natural gas upstream and midstream, geothermal, RNG for digesters, solar, and then a breakdown further into 3 of the key areas of AI data centers. So a lot of information out there. Each of these is intended to be for a manufacturer who's trying to decide, should I enter or expand in this particular energy supply chain? So that's how it's written. If you're not a manufacturer or you're just supporting the manufacturing industry, great. I think it's still going to be important information for you. But as you're looking at this, that's the idea, helping a company make that go, no-go decision. Am I a good fit? Is there, what information do I need to help me to decide if I want to move forward, or who I should talk to get more help in entering this area. So hopefully that's what you're going to see today. And very happy to introduce our speaker for today is Dr. Katherine Hornbostel. She is the department chair and professor of mechanical engineering at Duquesne University. She is very knowledgeable in this area of carbon capture, and she has authored and pulled together all this great content that you're going to see today. So I encourage you all to listen. If you have any questions, go ahead and type those into chat, and we will address all that we can at the end of the presentation today. And feel free again to reach out to myself, Matt, or Dr. Hornbostel if you have additional questions afterwards. If you didn't get the link already, and I don't have that link handy right now, but they're on our website, which is the first link that I sent out, is the place where you can download the carbon capture report. So if you haven't done so already, you can download it, and then it is yours to save and go and click on the links and do all that information as we go forward. So, Katherine, I will turn it over to you. Thank you very much.
Yeah, thank you, Tom, for the introduction. And this is being recorded, so if you miss something that I say, totally fine. You should get the recording link after. Also, that link is on my final slide, and I will share these slides with you all after as well. So it's totally okay if you miss something in your notes or need that link later. Okay, so today I'm going to basically give a very high-level overview of this report that I drafted. The full version is free and available to download at the link which I will provide. But first, in case you've never met me, just me in a nutshell, I was actually born and raised in Houston, Texas, went to Georgia Tech to get degrees in mechanical engineering for my bachelor's and master's. Then I went to MIT for my PhD, also in mechanical engineering. Went to Lawrence Livermore in the Bay Area for a postdoc where I first started working on carbon capture modeling. And then I was at the University of Pittsburgh for about 6 years, and then this amazing opportunity opened at Duquesne to become a department chair and launch my own brand new program. And it's been a really fun job so far. So now I'm at Duquesne, also in Pittsburgh. These are my 3 kids who keep me busy when I'm not researching carbon capture and teaching. Those are identical twin boys, so you're not seeing double. They're all really smart already. It's pretty fun to watch them grow and have different interests. And yeah, my research area is carbon capture modeling. More specifically, I do process flow modeling and device scale modeling. So what that looks like is using software like MATLAB or Python or Aspen to model different types of technologies that you could attach to a power plant or to industry to do carbon capture. This is one paper that I was on. It was an ARPA-E funded project where we modeled a really intense carbon capture system that's doing a mix of membranes, solid sorbents, and direct air capture to really try to hit net zero. So basically a natural gas plant with no emissions, which is pretty wild. As you might imagine, that's hard to do and it's expensive. So probably that's a lofty goal, but every molecule we capture counts. So it's awesome that you all are here to, consider ways to capture any amount of CO2 from different processes. So today I'm just going to go through kind of the same sections that are covered in the report in the order that they're presented. I won't dig into the weeds on this quick overview, but I highly encourage you to go check out the full report later. First of all, industry overview. So I am focusing on natural gas, but almost everything I say today also translates pretty naturally to industry. So things like cement and steel also produce carbon dioxide. So a lot of this technology applies there as well. But focusing on natural gas, this is a pretty recent pie chart showing how much electricity comes from different sources in America. And natural gas is the largest producer, so 43%. It's cheap, it's abundant, especially in this region. So it's probably not going anywhere. And it has some upsides from an environmental perspective over coal, which is decreasing pretty quickly. And this is a forecast, so it's not perfect, but this is estimates of basically the growth of carbon capture capacity for the US for the next few decades. And you'll see that the biggest kind of area for growth is electricity, and most of that is natural gas predictions. So really, in terms of the carbon capture predicted market for the US, natural gas is the biggest piece of that pie. But industrial sources are also in that mix. That's the gray sliver here. And so natural gas is growing, and basically the only way to continue doing natural gas long term and not produce a lot of CO2 or send it to the atmosphere is to attach carbon capture. So it's really important. And the way I like to think of it, if you think about carbon capture, there's a lot of types out there. You might have heard of direct air capture, for example. That's one that gets a lot of interest, but is a lot harder to do. And it's not really the first line of defense. I think this is kind of the lowest hanging fruit, if you will. It's attaching carbon capture to the source itself. So the tailpipe of a natural gas plant or an industrial emitter is the best place to go first for carbon capture. Good news is there is a lot of support, which you may already know about, at both the federal and the state level, if you're in Pennsylvania at least, for natural gas and industry carbon capture. So as part of the Biden administration, 45Q, which is kind of the federal incentive to do carbon capture, went up to $85 per ton of captured CO2 a few years ago. Before it was much lower, like $40, and this $85 really moved the needle in terms of incentivizing different industries to play in this game, because as you see in this little chart here, it typically costs at least $60 to capture a ton of CO2. So now there is some financial incentive from the federal level to do carbon capture. And the good news is, even in our latest political climate, 45Q seems to be doing well. It has not been removed, and even the latest I've read on, legislation, this is from May, and even more recently, there have been releases saying that 45Q is still being supported. It tends to be supported by both sides of the aisle politically, because there's a lot of different stakeholders that care about carbon capture and use. At the state level, there's also some incentive to do carbon capture and other forms of emission reductions through this RISE PA program, which is very much connected to the hosts of this webinar. There is an upcoming application deadline in August that you might want to check out. Actually, the link is down there right under this picture if you wanted to go check this out. I'm happy to talk to anybody on this call who, wants some input or consulting in terms of, what type of carbon capture would make sense for your particular industry to apply for this. It looks like a really cool opportunity to get some funding to look into carbon capture. Okay, there are still some challenges to overcome if we're going to scale up carbon capture for natural gas. First of all, at least for large facilities like a big power plant, this is going to be a large capital investment on the order of $1 billion. It's not cheap. Of course, that scales with the size of your system. So if you are a smaller emitter, you don't need to spend as much, but this can be a pricey undertaking. Another unique issue with natural gas in particular is that a lot of our fleet is designed to be peaker plants, which just means they kind of ramp up when needed, when it's like, peak electric load in the afternoon on a hot day, that kind of thing. If you look at our existing fleet, almost half of them are this kind of peaker design where they're just not operating most of the time. That's not great from a carbon capture financial perspective to have, it sitting idle for a lot of the time. So probably if we're going to do this with natural gas, it makes the most financial sense to attach it to this other blue portion of the pie. So stuff that's running more baseload power. Okay, so natural gas carbon capture, what does that look like? Here's the cute little cartoon version of what carbon capture and storage looks like. So step one, you find some emitting source. So whether it's a power plant or industry, there's a big flow rate of gas coming out of that combustion process where there's a lot of stuff in there like nitrogen, CO2, and other things. You have to filter that gas either through some sort of chemical process or membrane process to get the CO2 extracted out of it. That's kind of shown in this middle piece here. And then the CO2 typically gets compressed to really high pressures and sent underground, or sometimes it gets reused or stored above ground. So in our particular approach here, natural gas is this kind of blue box on the left. And the exhaust gas from a natural gas plant has roughly 4% CO2. A lot of the rest of that is nitrogen and some water and other things. That gas goes through some sort of carbon capture system. Usually it's pretty large. It has to handle large flow rates of gas. And then typically the benchmark has been 90% capture. So roughly 0.4% CO2 in the exhaust, and then a pretty pure stream of CO2 coming out for storage or transportation. Here's the more detailed, possibly overwhelming flow chart that's also in the report. And if you work in utilities or have seen before, this is actually a simplified version of what you would see in a real power plant. They are very complex systems. But let's kind of break this thing down. So this blue section here is a natural gas combined cycle. It's just a type of natural gas plant. So you're seeing like compressor, turbine, lots of heat exchangers, different stages of pressures for producing electricity, different turbines. And then this red section here would be a carbon capture system that you would send the exhaust gas. So this, if you can read 4, that arrow with a 4 on it is connecting the two. It's basically taking the exhaust from your power plant, sending it into this block that says CANSOL. That's basically a chemical that can do carbon capture. And then you'll see there's a lot of other stuff in here, though. It's not a straightforward single unit or like an air filter. It's a pretty complex utility kind of system with a lot of parts like compressors and dryers and, heat exchangers, pipes, all that stuff. And then this particular report where I got this flow chart from is focusing on what's called solvent carbon capture. So like a liquid chemical that kind of binds carbon dioxide. This is one that's commercially available. It's developed by Shell. And it looks something like this, that subsystem. You have these 2 big reactors where the first one takes in the gas from the power plant and has the liquid solvent in there to capture the CO2 out of that gas. And then that stripper column is basically where you heat up the solvent to remove the CO2 that's bound into the solvent so that you can keep using the solvent and extract the CO2. And if you want more of what's under the hood of this particular kind of system, you can go to this report that's in the reference here and also the report. This is like a really thorough report that's released every few years by National Energy Technology Lab, and they do a nice job really laying out the cost and examples of how we could do carbon capture for different systems like this. Okay, so kind of, based on that layout, this is my, component list that would go with that particular setup. This list might look different if you used a different technology for carbon capture, but it still gives a pretty good sense of the big categories that will show up in terms of manufacturing for this. I just want to break them into little, categories to help us kind of see from a high level, like what sort of industries would be tapped for this sort of a project. The first one that comes up is the chemicals industry. So you definitely need some sort of working chemical to do the carbon capture. That's called CANSOLV in this example. So that's a type of amine chemical that you can manufacture at a large scale. There's also ethylene glycol in this particular system that's used to dry the CO2 once it's captured. So there's definitely a need for the chemical industry to be involved in any sort of carbon capture project. Lots of pumps and compressors, and I didn't even list the column with flow rates, but they're huge. So these are big systems with probably a lot of parallel compressors and pumps. So definitely a need for centrifugal pumps, air blowers, or industrial kind of gas blowing technology. Heat exchangers, there's probably more than just this one, but this is what's shown there, a shell and tube heat exchanger. But I think anytime you have an industrial process, you're going to need heat exchangers. And then big reactor vessels. So that would be for the big absorber where the solvent is flowing through and capturing CO2, and also for the, I didn't even mention the stripping vessels. That's 2 that are under that first one. And then the CO2 dryer vessel. And there's probably others as well. So this kind of gives, and this is not comprehensive, by the way, these are kind of the big buckets that I could see. I mean, there's definitely things like piping and valves and, just other stuff as well to support this. These are just the big kind of items that show up. Okay, in terms of resources, because I can imagine if I were in your shoes, it's kind of overwhelming to try to, jump into a new technology or a new opportunity. So I would definitely encourage anyone interested in looking into this to look at DOE fossil energy carbon management as a starting point, which they are conveniently headquartered, DC, but also Pittsburgh. They have a big office here. This is really the main federal agency that oversees carbon capture and storage. So this is a great starting point. And within that link, you can find some other great tools. One of them is a list of current funding opportunities at the federal level. This Connect toolkit looks promising too, where you can see other potential partners or funding and, find other people to work with. Carbon Matchmaker also does a similar thing. So they have some really, they're kind of like the main overarching agency that handles this in America. So definitely a good place to start. To learn more about 45Q in particular, you could go to this link. It just shows you the different federal incentives for doing carbon capture. This one's also good. The National Carbon Capture Center is where they do pilot scale testing of different technologies. It's located in Alabama, also run by Department of Energy, but that's a great place to go if you're kind of trying to test out, a new carbon capture technology. In terms of regional places to look, I should have listed RISE PA. That's also great for, state level funding, but these are more like trade associations where you can get started and find some local partners in Pennsylvania, Ohio, and West Virginia. Okay, so now's the fun part where I am going to stop sharing this screen. So there's a few maps that are in this report, and they are screenshots from interactive maps that you can find online. So it's much more fun to actually share the websites and show you how these things work. And the links are in those slides, which I'm sending out. But just to give you kind of a peek at how these things work. So here's where the first one came from anyway. This is one that's an interactive map of all the power plants in America, broken down by sector and size. So if you filter and just look for natural gas, because that was kind of the focus of this report, that shows you where all the natural gas power plants are in America. It also, basically the size of each circle tells you the capacity roughly. So you get a sense of industry, and you can also zoom in, I believe. Let's see, there we go. So I live in Pittsburgh, so I'll zoom in there. I'm kind of curious too. So you can actually zoom in and click on them individually, I believe, and get lots of information. So kind of cool. You can click there and see details about the capacity, number of generators, CO2 emissions, all this good stuff. So this is a super helpful one to figure out not just natural gas, but if you're interested in others, you can also find other types of power plants in America. The second one is more specific to that fossil energy DOE funding agency that I mentioned. So this is basically all of the projects that have been funded by that agency for carbon capture. There's different application types like coal, natural gas. I'll filter for that since that's our area of interest here. But you can also look into others like, industrial. And I think we can also zoom here. Yep. Okay, so let's zoom in a bit here. And again, I'm partial to Pittsburgh, so I'm going to look at this one. Let's see what we can get about this. Okay. Maybe it doesn't tell as much information as the other website, but you can at least see which companies are, active or previously funded throughout America by fossil energy. And then finally, there's this map, which was developed by the Clean Air Task Force. It's US carbon capture activity. So this one's not just funded by that particular agency, it's more general. This one's cool for a few things. So first of all, you can break down by subsector here. It doesn't seem like they have one specific to natural gas, but they have like hydrogen, direct air capture. You could kind of filter or remove some that don't interest you. Or I think what I actually did for this map was get rid of all of them and focus on the CO2 storage, which is also pretty interesting. So you can see where all the underground storage reservoirs are in America. And this matters because you want to be close to one of these if you're going to do carbon capture and storage, because you need somewhere to put it. And we don't have great infrastructure yet for transportation. So good news is that in our region, we have lots and lots of capacity for CO2 storage. And you can even click on them and learn what types are available. And let's see if I can zoom in here. I mean, there's just tons right here in this region. You can look at all these different formations where you could put CO2 underground. No shortage here. So I think that is it for that one. So I'm almost done. I'm just going to share my slides again, just to kind of splash the last thing up there. Okay. So yeah, I'll just land on this final slide here. So this boxed in red link is the one where you can download this report that this is based on. Also the link to the EMA program that made this possible. Also up in the right-hand corner there, that's my email address and research website. I'm happy to follow up with any of you if you want to reach out to me and talk more about this. So I'm ready to take questions. So I don't know how you want to monitor or oversee that.
Yeah, well, thank you, Doctor. And I will say you took a very complex issue and boiled it down. I know this is not an area was very familiar with, so I appreciate that.
Thank you.
So now's the time we can stump the professor. If you do have any questions, submit them in the Q&A pod. Tom did drop in the link that so you can download the report. And the slides will be available as well in the recording to share it broadly. We'll get an email out here in a day or two. But we did have a question that came in via email, and it talks about subsidies. And as you mentioned, new administration, the technologies and what you're talking about with carbon capture, how reliant is it on having federal subsidies to make it work?
Yeah, it's a great and complicated question to answer. So subsidies play a large role in carbon capture development, unless you can find a good industry to basically reuse your CO2. So for example, enhanced oil recovery is largely what got carbon capture up and running initially, because there is some financial incentive to use CO2 to extract more oil. There are some other different industries like that where, you can reuse it for chemical, like for fuel production, or send the CO2 to Coca-Cola or some sort of niche industry. But from everything I've heard in the field, reuse is only a very small fraction of what we need to do. Really, most of the CO2 that we're producing needs to be captured and stored eventually. And as you can imagine, there's not really a financial incentive to do that unless you have some sort of, whether it's subsidy or carbon credit or some sort of, backing for that. And the way I like to think of it, I use the analogy of waste management, so trash collection. CO2 typically is a waste product chemically. It's on the right side of your reaction, so you're making CO2 as a byproduct of combustion. And we're making quite a bit of it right now. So the way I would encourage kind of government and other, policymakers to look at it is more of a kind of infrastructure kind of need. It's like, well, we don't want waste piling up in the street or sewage or any other waste product you can think of. There is a need to collect and handle it responsibly. So I do think there is a need for federal and state level support to do that. It's just kind of a basic need of society.
Okay. Well, thank you. I think that's all the questions. So, Tom, I'll turn it back to you.
Yeah, I would say, yeah, thank you very much. I think, again, I agree with Matt that you've taken something that can be complicated and complex and really kind of focused it down, especially on a manufacturer who may make a part or, have a service that they could be a part of this program, I think, to really help them understand. Although I have to say, looking at this drawing here by your daughter Evelyn, she may have made it even more simple.
I was about to say the same joke.
Yeah.
Really
after seeing that, I have a much better understanding of.
I love it too. It's like she thinks that when I drop her off at school, I just run around carefree with a net, catching CO2 like butterflies.
That's fantastic. Yeah, I really like that. Outstanding. But yeah, thank you very much. I think this is a great start to exactly what we're hoping to accomplish, is to help, certainly if we have someone on here who's already working in carbon capture, we'd love to hear from you and how does that process work. But I think this is really geared for companies or those who support or work with manufacturing to say, okay, I've heard about this industry, but I don't even know if there's a place for me or how do I get started. Chances are you're not going to be selling your product directly to, the largest, you might be looking at a second or third tier customer in that supply chain. So I think with the connections to the different associations and the other pieces. And I love those maps, those interactive maps. I think that's the first time I've seen the live demonstration. I've seen a lot of the screenshots of them, but yeah, now I'm going to go back in and play with those myself, because that looks pretty fun to see. Like, I'm surprised we don't have more natural gas power plants in this part of the country where we have so much natural gas. So that's curious to me.
Yeah. Well, thanks for having me. And as I mentioned, I'm happy to follow up with anybody in the audience. Please do send me an email. We can schedule a Zoom call or something to chat about your particular application, because I know it is an overwhelming kind of field to get into. So please do follow up.